Greetings to everyone. My name is, as you may know from the earlier presentation down in the plenary sessions, my name is Matt Foley. I manage the pre-sales team for what used to be called the Cloud Business Unit in HP. Now it's called the Hybrid IT Group. And it includes OpenStack as well as a lot of other related cloud technologies. This discussion here really is a description of the input model of OpenStack. So as mentioned in the plenaries and in a lot of other areas, OpenStack has been notoriously difficult to configure, set up, and use. And so we have taken, we've taken our lumps on it, I think, as a community, as well as directly in our own distribution. And we have done a lot of work to fix it, to actually make it something that is repeatable and programmable and professional in order to use. Same thing for the monitoring side as well, monitoring and also metering, which are the other important topics that we have in cloud. Just quickly before I start, how many of you are using or have used the Helion OpenStack distribution? Okay. Just wanted to make sure I didn't have like everybody's hand go up and then we could all go out. But so welcome, and welcome to those of you who haven't been introduced to the distribution before. Just by way of trivia, Helion was a name that was come up by the marketing folks. It actually was a reference to Helios, the sun god, in terms of being above the clouds. That was the whole point behind the name. So all sorts of things. So with regards to what it is we're trying to do from an enterprise grade perspective, we want to bring forward the operational experience and the policy definitions that you need to have in order to successfully operate a cloud in an enterprise setting, in order to have the kind of auditability, the kind of traceability, the kind of data that you need in order to defend the actions that you take in terms of configuration and use. And that's important, right? From an IT perspective, one of the requirements I used to say is that we try not to get our customers fired, right? And that's the point. And so we want to make sure that we have a lot of these points in here from control, and then with regards to the global support. The open source alternative piece, this is, of course, what OpenStack is all about. It's what HP has believed in for quite some time. Dating all the way back 20, 30 years ago to some of the earlier foundations of Linux. With regards to OpenStack and what it is that we put in there, so our distribution, we start with the trunk code. And we contribute significantly to that. If you look at the Stackalytics site, HP Enterprise has been 1, 2, or 3, I think, for every release, going back a few years. And we do have a significant number of engineers working on it, and in some specific projects like Freezer, we've been leading. We also did a lot of contributions to Neutron. So this has been for us a very important exercise. From a security perspective, that's an area where we felt the need to contribute, I think, the most. So we take the open source trunk code for the community, not just for us. We take the open source trunk code and we run it through our Fortify tool, which is a code checker or a testing tool that exposes vulnerabilities and security vulnerabilities in code and gets them fixed. And so in that way, it hardens the entire ecosystem code, not just our particular contributions. Of course, we contribute anything. We contribute most everything back into the community, and then the key value add pieces. We're on the parts that were really talked about a lot today. They're on the installation and configuration side, as well as the monitoring and control side. Those are the areas where we have invested the most. And if you look at it from our hardware perspective, and that's a world where I've come from in the past, that's also how we tried to differentiate in hardware, was through management experience. So we wanted the systems to be standard and run the standard operating systems and standard applications, but at the same time, we wanted them to have a superior management experience. And that's what we've tried to do here in software as well, is provide that. Another area we're differentiating and trying to is in PCI readiness, or for the standards that we support in the security domain. And it's important to know that a product itself cannot be PCI DSS certified. The product, however, does support, with the right business processes, the certification effort of a customer with their business processes. So we have made the changes to the code in order to enable that. With regards to the configurability, so we want our customers to be able to express the architecture in a programmatic, straightforward way, and I'll show a lot of that later with, I know you guys will just be excited and thrilled to see like scripting code on the screen, but it's just great. There's nothing better than that on a Friday afternoon, right? So we express the architecture through those scripts and through those programmatic interfaces. We do the integration work with the data center is something we feel really important. That's a key thing. We can't have, they used to say no man is an island, and really no application should be an island either, and that we can't just have all these data center or all these applications in the data center be completely siloed. If you want to see an industry that is completely siloed, look at telecom. Right, so from a telecommunications perspective, inside of the network, the network side of that, often what you find is an operational computer museum. Right, they have essentially one of everything, and it's very difficult to use all those management frameworks at the same time. So we try to make sure that this is integrated and integrated well. The other part is the repeatability of the experience. Can you take the cloud that you built and spin up another cloud exactly the same way in a different data center? Can you do this repeatedly? Or can you roll back to the upgrade that you just made where it broke the cloud? Can you roll it all the way back? We can do that, as you'll see. This is the architecture of the running environment, of how it is that we run this. So you can see Horizon and then all of the typical services, Keystone on the side, Manaska and Salameter on the bottom. We have been, in the OpenStack world, we have just played, buzzword bingo with all of these names, right? All this stuff, and we go around and speak about that. The areas where we've contributed significantly, I would say, are Barbican and Neutron, and then from a Cinder perspective, we contribute our storage plugins to that. Everybody works on Nova. Ironic has been an important thing for us because we're trying to use different or alternative hardware in Ironic, and so this is how we have alternative platforms, like there's one called Moonshot, and what that was, it's essentially a box of cards, where it's could be a box of graphics cards or a box of DSPs or other different, almost custom hardware. We would like for that to be supported and accessed as resources in OpenStack as well, and so that's one of the areas that we think Ironic can be used in order to further integrate those kind of platforms into a data center. And then the additional targeted contributions that we have. So from a production services perspective, that's really where we're at. I mean, as experimental as OpenStack has been, and it's been frustratingly experimental at times, we are able now to run production. We're able to run production because we have this deployment and lifecycle, and you can actually see this Helion Lifecycle Manager. It's been open sourced. Kind of. So it's available on Git, but it's read-only. But fundamentally, it's been open sourced. We have our security activities here where we have all these key stores as well as the encryption of the data at rest as well as the data in transit. And then this management and operations piece has been difficult. And the reason why it's difficult is because those services, when you scale them and they monitor more and more things, you wind up with all sorts of clashes, and you wind up with all sorts of log overfill and those types of things. So what we have found, and this number here, just to my view, it feels low, right? Back when I was doing hardware, and this was back in 2006, I started working with Intel. Intel is the customer. So Intel, those of you who don't know, Intel has an enormous design IT cluster. Back then, in 2006, it was 100,000 servers running Verilog, tape out, all of these sorts of things. It was gigantic, and it was spread over all sorts of parts of the West. And they switched from IBM's blades to ours at the time because we introduced C-Class, and it was really kind of a hot product. And they bought, in their first order for their data center in Portland, Oregon, they bought 3,360 blades, 70 racks of blades. And so when I look at this, and I go 200 compute nodes, right? I mean, Intel had like wall-to-wall of these things. But the reason why this is difficult, and the reason why a distributed computer is difficult, is because we have to drag all of the services to all of those 200 nodes. And so some of the services in OpenStack could scale just fine to the 3,000 nodes, or however many Intel wound up having, and that was kind of a fun time. But the fact is that if we're working with the OpenStack nodes and working with all of the services that are required for an enterprise distribution, you find that some of them don't scale that well. And that's what we found in the monitoring and metering part. So we are working to expand those, and we've got professional services to help expand those and make those better. But that's the reason why sometimes you'll see what seems to be a lower number than you'd expect. It's certainly a lower number than what I'd expect. And as the pre-sales guy, I'm having to ask the questions back to the R&D people as to what's going on, but that's what it is. So here, and this is a video, I'll play it in a second, it's only a minute or so long, but this is the OpenStack experience. So I remember we did a proof of concept at a large German, one of the large German industrial companies, and that was with, gosh, it wasn't even with Helion 1, it was with the Community Edition, which never should have been produced. But basically it was with the Community Edition of the software and the Community Edition of Cloud Foundry as well. And we went there and it was a week's worth of pain, right? Nothing but pain. Here comes your OOO images, let's put this on the system, all this sort of stuff. All the things that we said about it being highly available were true, except for the fact that the DNS server ran on the seed node, and if that thing died, the whole thing died. So, I mean, it was brutal. Well, now what we have here is we have this day zero installer, and you'll see it, it's actually a wizard. And then this can create, or it creates an input model, which is apparently causing this stuff. It creates an input model, which goes to a configuration processor, which outputs Ansible scripts. And these Ansible scripts are then run in order to direct cobbler, to bare metal provision the system, the servers that you've defined. And most importantly, and this is the part that when they first presented it to me, it went sort of, aha, you've got it now. There's an internal Git repository inside of the distribution. And so you have, say you've added an update to a specific project, or you've added more machines, or you've added something that's different to your cloud, you can save effectively a new cloud, a new configuration file for a cloud. And if that doesn't work, you can roll back to your old cloud because you have all of the scripts to go and rebuild that. So that Git repository, just putting this in there and having its repository means that the infrastructure is really coded. And that's how it's built. It's built from these files. And then that's how it's repeatable, that's how it's auditable, and that's how you're able to then really manage it in I think a much cleaner way. So let me go ahead and start the thing. There it goes, yeah. So it's starting, and this is ILO. God, I love ILO. That's been there forever. So basically, we're just telling it where to go, and this is essentially a quick startup here. It installs the base system. We run an init file to initialize the first part here, and then we get into the wizard. And so then this wizard, we're looking at an entry scale cloud. This is a stock cloud there. You've got different roles. You have then different server roles, and you type in some of the nettlesome details, right, in terms of IP addresses and MAC addresses and whatnot. So you still have to have some of that manual input, but at least it's not, hacking a text file. And then you're able to change where these things are and what kind of roles you have going forward. And then what it does is it builds it. It builds the cloud, and then you wind up with, with something you can log into and show that the cloud's been built. And so for us, what this did, though, was it allowed our customers to at least buy a product that we could put together, or they could put together for a simple cloud. Because before, what we did was we put every service on a bare metal server, which was crazy in some ways, because we would go into proof of concepts against other competitors with distributions, and they had implemented a virtual control plane, and so they needed 1 or 2 servers, a virtual control plane, have people test and play with OpenStack, and we're like, first thing you need is 7 servers. Go find 7 servers in the demo pool, get them there, plug them in, turn them on, load them up, and then have this have some of the craziness that OOO had. We couldn't even determine roles. Actually, roles at that time were determined dynamically, if you will. You basically got what you got. So this is a vast improvement over that, and I'll describe how the input model does that or helps with that after this. This here is the Helion Ops console. So in the back of the system, really, there's the Ops console, which is the operations dashboard, and it combines the outputs of Kibana, Logstash, Elasticsearch, and Monasca, and puts them all into a page where you can actually do something with this and figure out how your cloud is operating. And here, what this video will show, real quick, is this video shows the ability to look at the system holistically, and then also check alerts that are there, and actually define an alert and see that alert failed. By killing the Nova service is what they do. But okay, are we going? Yes. So it's going, so now it's checking for new alerts, and then you can go and figure out what it is that you see. There are problems in the storage domain, apparently. But the other place is you can then define alerts. So you can actually take and go ahead and create a new alert if you wanted to understand a specific issue or a specific way that your cloud was operating. And then here, what they do is they just go and kill the Nova service, and then prove later that the alarm was able to catch that it was gone. The idea, though, is that we didn't have quite this much of an operations console in the past, and it was more difficult to administer and manage the cloud and find all of the logs and all the problems in one spot. And that's really what we've tried to do. Yeah.
Is this an open source?
This part is this is the proprietary part of the distribution. So this part is an open source. So the ops part is an open source. Much of this part here, this configuration part, this is open source actually. The input model and the configuration, we have open source that. But the ops console that you just saw, no, it's not. Although it's probably pretty close to being open source really, but it's not today. So with regards to the cloud model here, two things. So you've got the things that are defined by Helion OpenStack. These are namely the services that are required in the distribution, the services that the distribution comes with. And then everything else you'll see is configurable. So we start with a cloud, and the cloud consists of control planes. And then from there, the control planes run one or more of the services. So we have the Nova server, the compute controllers, all of the other controllers that run in OpenStack. So that's where the services are, and that's what the control plane does. The control plane consists of has really server roles. So they use the servers with the particular roles of I want a specific controller node in order to run my services, to be the API endpoints to drive the rest of the cloud. And those server roles, of course, are defined by the servers which have those roles. So we have a whole stack of servers, and we've defined roles for those servers, and so it goes and finds those roles there. And then those servers themselves can actually belong to a group. And why this is important, this is where you can define things like physical separation of your data center. So my server is in group A because it's in the first rack, it's in group B in the second rack, it's in group C in the third rack. And so you can define that you have this sort of physical separation in your logical domain. So you can put the controller nodes in separate racks so that they don't all fail if one of the racks loses power. And you're able to match that physical and virtual space. That's an important thing. That was one of the hallmarks in previous generations. We always wanted our systems to be location aware, and that became increasingly difficult as the industry moved more towards pizza box servers. But as we created different hardware to be location aware and smarter racks, that helped. And it's important because you can find out a lot about the physical environment. You can find out temperature and all of those sorts of things on the physical servers. So being able to put your cloud into the right server in the right spot in the rack, that's important to understand that topology. So we have these server groups. In addition, servers not only have roles, they're also connected, they also have NICs. And so these NICs are mapped to encompass network points or endpoints. And the server not only has NICs, it also has disks. So there are drives in the server. And so it's important in the server role to determine the kind of disk models that you're using. Are you a storage node? Are you a controller node? And so forth. And so that's an important thing to have there. Let's see. Then we have networks. So the network is part of the network group. And then those network groups, all the endpoints are attached into the services and how those services work and the way that those services are then controlled. Beyond that, the server role actually has an interface model which talks to the network groups in terms of how it's connected or which specific groups get connected. This is where we can also define bonding in there. So famously in the first edition of Helion OpenStack, we actually couldn't do dual NICs. We couldn't bond things. Now we can, which is good. It's nice to come forward 20 years, but anyway, we can do this. It's great. And so it's good stuff, actually. So we have all of those areas. But the thing that's important is, remember before, in the first part of the slide, I said the yellow stuff is defined by host and everything else is configurable. Well, all you really defining are the services initially in Helion OpenStack. Everything else is determined by your particular hardware constellation and configuration. The servers that you have, the NICs that they use, the disks that are in the server, the roles that they have in terms of the control plane, where everything is. You define all of these in the input model. And then this is the material, this is the input that gets passed into the configuration processor, and that's where the Ansible scripts get created so that the cloud can be built. That's how it works. And so it appears complicated, which is why we put a wizard in front of it and all of these sorts of things. But in reality, because all of this is saved programmatically, because all of this is saved as code and all of it's saved in a code repository, it actually makes it, a professional experience. We're actually able to do this and redo this. You're not in kind of an in loop or in a mess. So then there's some last pieces there. So the control plane here, the control plane is used to server and network from one of the more server groups. So now I'll go to a different slide, and it shows in some ways the same thing. So the services are up there, but here what I'm showing isn't necessarily that. It's like, for example, in the control planes, we define here the control planes, what the services are that they will have, as well as the resources here. So for a compute server, for example, we'll have these resources available. Same with VSA, which is our block storage part. From a server group perspective, this is where you define the servers in the different racks, if you wanted to go that way, or different areas. So this is where all the servers, regardless of whether they're control nodes or payload nodes, all of the servers can be defined into server groups so that you can have that physical isolation if you choose to, and you have better control of it. Server roles, this is where you define the roles, controller, compute, VSA role for storage in our case. The servers themselves, this is where you say that you were fortunate enough to purchase high-quality HP material in the DL360 here, which is a fantastic product. It's our 1U server. For those of you who don't know it, the 380 is the 2U. Just anyway, those are the areas where we have these different controller nodes and things defined in terms of what the servers are. We take it from there, of course, and you can map, actually the other way. Take it from there and you can map the NICs, the NIC bindings there. And you just walk through this in terms of the interface model, but all of these are these interfaces that get created and get used. And so from that, one of the areas that we can do is not only do we have all of these input files that describe your environment, we can provide you with suggestions. And so, for example, this is an entry scale cloud with KVM, and so the distribution comes with examples. And comes with, if you would like to build a cloud that looks like this, these are the scripts that you would use as input models in order to go into the environment and build your cloud. So it gives you a starting point of a complete finished example of, in this case, a small cloud that describes all of the networks here that we use. There's the management, the API, the external and the guest networks, and then the actual nodes themselves. These are storage, compute, and control planes. And you can see where we have different amounts of node counts that we've tested this with. So 100 nodes in terms of compute, 3 control plane nodes. Normally we have that for just the redundancy. The high availability requires 3 nodes because you always have to have an odd number of nodes for quorum. And then the physical network or the bonded NICs. But this is already there. It's an example, and we can go further, of course, in that we have different examples in terms of the medium scale cloud here. The control plane is bigger. There's different object stores, but you can see here we've separated out into 3 different racks. We have plenty of different networks, so we have different specific storage networks here that we have defined and used inside of the cloud. You can see where here that one of the things I've always found in cloud is that there's sort of a mental assumption that everything that you just have these control nodes sitting over here, like we used to have management software just sort of sitting over somewhere in a corner, and then everything else is payload. And what we're finding in cloud builds and cloud construction is that it's better to just spread the control nodes over and across the environment, take advantage of the physical separation, take advantage of some of the load balancing, take advantage of all of the spread here of services, and they are fundamentally cloud services themselves, and just really mix it all together. So that's why this can be even more complicated in some ways, is because you've got a variety of uses for these nodes. The hardware itself is basically all standard. You may want more disks for your storage node, but in general, the hardware is almost identical no matter what service you're running. And so these are just how the personalities of the servers really get assigned. So it's important to have those kind of examples, because if we don't have these examples and we don't have the ability for you all to use them, then the whole input model falls apart, because you really try to sort of hunt and peck and define everything that you have. So that's why we start with these, and that's why we're confident and happy about the configurability. And we've seen it in the field. So for example, we have at least heard anecdotally that when we quote an installation, it's significantly shorter than folks doing installations on other distributions. And the reason is because we've got all of this together. And that's been helpful. It's helpful to services teams because they don't have to spend as long. It's helpful to customers who are doing it themselves. Now, back to your question earlier as to what's open source and what's not. So the parts here in green are not open source. Everything else is open source and either part of the OpenStack Liberty distribution, which is what this is. So we will have an OpenStack 4.0, which will replace all of that with Mitaka. That'll be right around the OpenStack Summit in a month. Plugins from the various services. HP Value Add is in the darker area. We hope it's valuable. We call it value add because it's ours, but nonetheless. But it's also open source. So this is where, for example, in the user interface, in the ops dashboard, that's where, and the storage and the zero-day installer, those are all those GUIs, right? So those GUIs aren't open sourced. But the configuration processor is. And the deployment article, and the boot images, service playbooks, all this sort of stuff, all of that is. All of that's available, and that's what we've actually put up onto GitHub. The provisioning service is open source, and it's not even ours. It's Cobbler, which I believe is owned by Red Hat, if I'm not mistaken. Then we have all of these other different areas, things like MySQL, RabbitMQ, the service failover management, all of these other services that we've put in here in order to make sure that we have the enterprise type of reliability that we're looking for in terms of HA and service description. And we always put in Ceph, which drives me crazy because we always put in the wrong version of Ceph. There's just nothing, you never, apparently you can never get the right version of Ceph, is what I can tell. But for whatever reason, we've integrated it in here. Oftentimes we see people use another one anyway, because we've got Firefly in here now, and I think it's Hammer, and then there's a few others. But anyway, Ceph is there, if anything, just to distract me. And for our block storage, we have our own VSA, which is our software-defined storage. It has its heritage in left-hand networks. It is a pretty hardened actual product from a block storage perspective, and so we've used it here. Vertica is a database as well that's been popular and well used. So with that, don't have much else. We can put that up for a while if people want to talk about it or think about it. But I really don't have much else. I wanted to really walk you, though, through this input model and understanding of how these clouds are built, because for us, this is a key differentiator and a key thing that enables OpenStack to become more mainstream. So if you don't need if you don't need all of the extended time and pain and everything that we used to have installing OpenStack, we believe that it can become more popular. And that's what we've done, and that's what we found, and so we're proud of that effort. It's also why we've communicated it back to the community and delivered it back to the community, because we believe that that's been maybe the biggest pain point in OpenStack. It hasn't been so much using it, it's been building it has really been the issue. And so we have done all of this work in order to do that. And those are typically the value adds you're going to find, I think, in distributions generally, is you'll find that the value adds are in the initial installation experience and in the management experience. Because if you really put value add in, say, for example, the compute side, all of a sudden you're proprietary, or all of a sudden you're non-standard, which kind of defeats the whole purpose of of being open, of OpenStack anyway. So we're always having to ensure that we stay on the right side of the line of adding enough things to make it useful while not destroying the OpenStack or the openness of it, which is really what people are buying into when they're trying to when they want to use open source software. So with that, downstairs in the exhibit hall, there's a Hewlett-Packard Enterprise booth. I think it's kind of on the back wall. It's over kind of towards the left, towards the back. And there, if you would like this distribution, we have it available for you. In fact, it's on a USB key. So you can get it, right? Just go get it, take it home, use it. And it has the things that we talked about. It has the scripts in there for building clouds. It has the materials that you need in order to share that. So you can use that. If you would like to build it with help, so we have consultancies with Fairbanks and Kangaroo, both of whom are here in this event. And then we also have Dutch and I think as well as Belgian, actually, service providers, Amsio and Stewart, who can offer this as a consume option as well. So if you'd like to test out Helion OpenStack in a consume space, we have service providers who offer that today here in Benelux. We have service providers elsewhere that do it as well, but here in Benelux we have that. This other logo, by the way, in case you're wondering, this thing is called Cloud 28. So here in Europe, we've worked a lot in terms of Cloud 28, in terms of trying to democratize and build up the cloud market with homegrown providers and homegrown solutions. And that's what Cloud 28 was about. The 28 refers to the European Union, so presumably it's 27 now. But nonetheless, that's the point. The point is what we were trying to do is we're trying to make sure that we have we have a healthy market for cloud, which is also another point in OpenStack. We don't want to be, far be it for me to say, but not everybody wants to outsource their data sovereignty to the United States. It hurts me to say that, but nonetheless, it seems to be true. So we want to make sure that people have local options, and that's the reason why we're trying to develop these technologies and make them usable and develop the communities around them to make them commercially successful as well. So with that, I am getting the hook, and I thank you very much for your time and attention, and I wish you a good day.